Hello students, here I am back with another lecture of the same chapter that we have studied last week, periodic classification of elements. I hope you all have enjoyed that video and most importantly, you have understood all of the concepts that has been taught to you in that. So here are the further topics of the same chapter, periodic classification of elements. So let's move forward. Let's recall whatever the concepts that we have studied in the previous lecture. We have studied about the Dobrynin's triads. Whenever the elements are kept in the increasing order of their atomic masses, the mean of the first element and the third element, the mean of the atomic masses of the first and the third element will be the result of the will be the result of the atomic mass of the middle element. Newland's law of octaves. Whenever the elements are arranged in the increasing order of their atomic masses, every first element and eighth element shows similar properties. This is the Newland's law of octaves. Next is Mendeleev's periodic table. We have studied in the previous lecture about the Mendeleev's periodic law that whatever the elements, the properties of the elements are the periodic functions of their atomic masses. What Mendeleev has told or what Mendeleev has stated that whenever the elements are arranged in the increasing order of their atomic masses, the properties, the physical or the chemical properties, they repeat after the certain intervals of time. Then we have studied about the merits and demerits of the Mendeleev's periodic table. The whatever the advantages were there over the previous classification and the demerits of the Mendeleev's periodic table, that whatever the limitations were there in the Mendeleev periodic table. Understood? Next topic that we will be studying in this chapter is modern periodic law. We have already studied Mendeleev's periodic law or Mendeleev's periodic table, and we have seen that there were demerits or limitations in the Mendeleev's periodic table. So to tackle that limitation, the further classification was done, and that was modern periodic law. Let us study about the modern periodic law. The scientific world did not know anything about the interior of the atom when Mendeleev put forth the periodic table. After the discovery of electron, scientists started exploring the relation between the electronic number of an atom and the atomic number. And they found that whatever the number of electrons are there, it is equal to the number of atomic number. Are you getting it? For example, sodium. Sodium has 11 electrons in their orbits. It means that the atomic number of sodium, it is what? It is 11. Whatever the electron number are there, it is equal to the atomic number. In 1913 AD, the English scientist Henry Moseley demonstrated with the help of the experiment done using X-ray tube that atomic number of an element corresponds to the positive charge on the nucleus or the number of protons in the nucleus of the atom of that element. See, what Henry Moseley has demonstrated in his experiment, that the atomic number of an element, they corresponds to the positive charge. And what was that positive charge? That positive charge was a number of protons, or you may call it as that positive charge was on the protons. So this revealed that in the nucleus, protons and neutrons are there. That protons are the positive charge ones and neutrons are the neutral. It means that they don't have any charge. And electrons, they revolve around their orbit outside the nucleus and they possess negative charge. Are you getting it? So this revealed that the atomic number is more fundamental property of an element than its atomic masses. Mendeleev has told that the fundamental property to classify element is atomic masses. But what Henry Moseley is saying right now, he is saying that the fundamental property to classify the element, it is not atomic mass, it is atomic number. And this theory shook the entire scientific world at that time. But this theory proved to be very useful method or very beneficial for the classification of all the known elements at that time without any limitations. Whatever the limitations or demerits were there in the Mendeleev's periodic table, all of the demerits were removed. All of the anomaly were removed in the modern periodic table. Are you getting it? So, what is modern periodic law? Properties of elements are a periodic function of their atomic numbers, not atomic masses. Mendeleev has told that properties of elements are a periodic functions of their atomic masses. But modern periodic law state that properties of elements are a periodic functions of their atomic numbers. It means that whenever the elements are arranged in the increasing order of their atomic numbers, and after certain interval of time you will find that a element is repeating its properties. So whatever that element are there, you will pick that element and you will put one below the other. In this manner the periodic table will be made, and this periodic table that is arranged with the help of the atomic number, it is then called as modern periodic table. Understood everyone? Next topic that we will be studying is modern periodic table, that is long form of the periodic table. This is a modern periodic table. I have taken the image from your textbook itself so that you will understand it clearly. So what are the characteristics in this table and what is the all the specialty of this table we will be seeing in this chapter. The classification of elements resulting from an arrangement of the elements in an increasing order of their atomic numbers is the modern periodic table. See, I've already told you that whatever the elements are there, when you arrange that element in the increasing order of their atomic numbers, that becomes the modern periodic table. As a result of this kind of arrangement, the drawbacks of the Mendeleev's periodic table was removed. See, I will let you see this example about the cobalt and nickel. In the Mendeleev's periodic table, nickel were placed before cobalt. But here you can see that the cobalt and nickel is placed one after the another. This was one of the drawback of the Mendeleev's periodic table. It was arranged in the Mendeleev's periodic table based on their atomic masses. But here it is arranged based on their atomic number. At the top that you are seeing, it is the atomic numbers. We will be seeing it further in the structure of the modern periodic table. So this anomaly was removed. However, the ambiguity about the position of hydrogen is not removed in the modern periodic table. See, there was this demerit about the position of hydrogen in the Mendeleev periodic table, that the hydrogen resembles the properties of alkali metals also, that is this first group also, and the halogens, that is 17 group also. So this ambiguity, it is not removed in the modern periodic table also. So hydrogen, you may see that it is one of the lonely element, that it doesn't have a specific place, a fixed place. It resembles the property of alkali metals also, and it resembles the properties of halogens also. So that is why this demerit was not removed in the modern periodic table also. Understood? The relation between atomic number and electronic configuration is clearly seen in the modern periodic table. There are lots of relation between the atomic number and the electronic configuration in the modern periodic table. We will be seeing it in the further chapter. Let us study now in detail about the modern periodic table. Following is the video. You see that video, then I will try to explain you the modern periodic table. See, as you have seen that all of the components of the modern periodic table is indicated by a certain names. You can see here this first group, it is called as alkali metals. The second one is called as alkaline earth metals. Are you getting it? And for your further understanding, this modern periodic table can be classified into four groups: S block, D block, P block, and F block. All of these concepts will be studying in the further topics. These elements that is present in the D block, it is called as transition elements. The group of carbon, it is called as carbon family, nitrogen family, oxygen family. This 17th group is called as halogen family. And this 18th group, it is called as noble gases: helium, neon, argon, krypton, xenon. These are all the noble gases. And the below the periodic table, F block is made. This F block is lanthanide series and actinium series. You can see the star and hash given here. These are lanthanide and actinide series. Actually, they are at the back of the periodic table. These all the elements, they resemble similar properties. They resemble similar properties. That is why they are put it in the one box, and all of these elements, they are arranged at the back of the periodic table. Are you getting it? So you cannot study the back of the periodic table in two-dimensional. So that is why it is given, always given below the periodic table. And this is called as lanthanide and actinide series. Are you getting it? In the modern periodic table, we have seen that it is arranged based on the atomic number. You can see this. Hydrogen atomic number 1, helium atomic number 2, 3, 4, 5, 6, 7, 8, 9, 10, like this. Are you getting it? Moving forward, we will be studying the structure of the modern periodic table in the further chapter. Let us see. I hope that few of the components of the modern periodic table you have understood till now. Let us study structure of the modern periodic table. In this topic, you will get to know the modern periodic table in a more detailed manner. The modern periodic table contains 7 horizontal rows called the periods 1 to 7. See, modern periodic table, they consist 7 rows or the periods 1, 2, 3, 4, 5, 6, 7. Do not take the concept wrong. When you say periods, it means that you have to go left and right, left to right. You have to see left to right. See, in the first period, there are two elements, hydrogen and helium. In the second period, there are these elements, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Are you getting it? When I say periods, it means that you have to see left to right. So there are total 7 periods in the modern periodic table. See, 1, 2, 3, 4, 5, 6, 7. These are the 7 periods in the modern periodic table. Numbers 1 to 7. If I say sodium, it is in which period? See, 1, 2, 3. Sodium, third period. If I say sulfur, it is in which period? 1, 2, 3. Here there is no element, but this will be taken as a period only. Are you getting it? 2, 3, third period. Is that clear? Similarly, 18 vertical columns in this table are the groups 1 to 18. Are you getting it? See, whenever I say groups or columns, you have to see top to bottom. 1, 2, 3, 4, 5, 6, 7, 8. Are you seeing it? 18 groups are there. Whenever you say it as group, you will call it as what? You will call it as a top to bottom. You will see it as top to bottom. Understood, everyone? So, in the periodic table, in the modern periodic table, there are how many periods? There are 7 periods. And there are how many groups? There are 18 groups or 18 columns. If I say calcium, it is in which group? Calcium is here. Come on, second group. Are you getting it? Atomic numbers are serially indicated in the upper part of each boxes. In each of the box you see atomic number, it is indicated at the top of the box. Apart from these 7 rows, 2 rows are shown separately at the bottom of the table. These are called lanthanide and actinide series. See here, this one. Lanthanide and actinide series. It is named after their first element, lanthanum and actinium, and their position is here. Understood, everyone? And they are made into a series because all of these elements present in the series, they resemble almost similar properties. Is that clear? All 118 elements discovered were successfully placed in the modern periodic table. All of the 118 elements, see 118 elements. Do not get confused here. See here, 57 to 71. It is here, 57 to 71. 89 to 103. Here, 86. 87, 80, 89. 89 to 103, 103. They are put here. Understood? And further, till 118 elements were discovered, and all of the 118 elements, they have been classified successfully in the modern periodic table. Understood? Further structure we will be seeing in the next slide. Structure of the modern periodic table based on the blocks. There are 4 blocks. The entire periodic table is divided into 4 blocks with S block, P block, D block, and F block. These are the 4 blocks in which the periodic table can be classified. S block, groups 1 and 2. See, groups 1 and 2, S block. Then second one is P block, groups 13 to 18. They consist of what? They consist of the P block. Then comes D block, groups 3 to 12. D block, groups 3 to 12, D block. Understood? F block, that is lanthanide and actinide series. This is the F block. Understood? So the entire periodic table is also divided into 4 blocks, that is S block, P block, D block and F block. Understood? These all the blocks have certain names, that is S block is called as normal element, D block is called as transition elements, F block is called as inner transition elements. Understood? A zigzag line drawn in the P block divides the table into 3 traditional types of elements: metals, non-metals and metalloids. This is also one of the method to classify the periodic table. You can see here this zigzag lines. Are you seeing it? In the zigzag line, whatever the elements is sitting, arsenic, tellurium, silicon, they are metalloids. See, these are metalloids. And on the left hand side, this area, they are all metals. Are you getting it? On the right hand side, this area, they are the non-metals. And whatever the elements sitting on the zigzag line, they are what? They are the metalloids. We have seen in the previous lecture about the concept of metals, non-metals and metalloids. All the metals lie on the left side of the line, while all the non-metals lie on the right hand side. Metalloids lie in the border of the zigzag line. Understood, everyone? Next concept that we will be studying is electronic configuration. For understanding modern periodic table clearly, you must understand electronic configuration. Here is the video for making you understand about the electronic configuration. Hope you will understand it. Say it.
Electronic configuration of elements. According to the Bohr's model, an atom consists of a central part called the nucleus, which contains positively charged protons and electrically neutral neutrons. The number of protons in an atom is called its atomic number and is represented by Z, while the sum of its protons and neutrons is called its mass number, which is represented by A. Besides protons and neutrons, there are negatively charged particles called electrons, which revolve around the nucleus in various shells or orbits. This arrangement of electrons around the nucleus of an atom in various orbits is called its electronic configuration. Please note here that the number of electrons in an atom is always equal to the number of protons, which makes the atom electrically neutral. Every orbit has a certain capacity to accommodate electrons. According to the Bohr-Bury rules, the maximum number of electrons that can be accommodated in a particular orbit is determined by the formula 2n squared, where n denotes the orbit number. For the first orbit, n is equal to 1. Therefore, 2n squared is equal to 2. Hence, the maximum number of electrons that can be accommodated in the first orbit is 2. Similarly, for the second orbit, n is equal to 2. 2n squared equals 8. Hence, the maximum number of electrons that can be accommodated in the second orbit is 8. Although the third orbit can be occupied by a maximum of 18 electrons, when 8 electrons are occupied in the third orbit, a certain degree of stability is given to the atom. Hence, the next electron, instead of entering the third orbit, goes into the fourth orbit. For example, the atomic number of potassium is 19. Therefore, there are 19 electrons revolving around the potassium nucleus in the potassium atom. Out of these, 2 electrons enter the first orbit, 8 in the second orbit, the other 8 enter the third orbit, and the remaining 1 electron, instead of entering the third orbit, enters the fourth orbit. Hence, the electronic configuration of potassium is 2, 8, 8, 1. The electronic configuration of an element also helps us to decide the position of an element in the periodic table. The number of orbits or shells denote the period to which that element belongs. Let's continue with the same example of potassium. Its electronic configuration is 2, 8, 8, 1. This means there are 4 shells in an atom of potassium, and therefore it belongs to the fourth period of the modern periodic table. Similarly, sodium with 3 shells belongs to the third period. Lithium with 2 shells belongs to the second period. Rubidium with 5 shells is placed in the fifth period, and so on. The number of electrons present in the outermost or valence shell of an atom decides the group number of that element. Thus, potassium with 1 valence electron fits into group 1 of the modern periodic table. Magnesium with 2 valence electrons is placed in group 2. Aluminium with 3 valence electrons belongs to group 13, and so on. However, there are a few irregularities shown by some elements in their configurations, such as that for chromium, copper, silver, gold, etc., which we will study in a separate topic. Despite these irregularities seen among the elements, it is possible to predict the position of most of the elements in the periodic table from their configurations, and vice versa. Summary: we have seen that the number of protons present in the nucleus of an atom denotes its atomic number, while the sum of its protons and neutrons denotes its mass number. The atom is electrically neutral as it has the same number of electrons as protons. The number of orbits in an atom of an element tells us the period to which that element belongs, while the number of valence electrons decides the group number of that element in the modern periodic table.
So, as you all have seen, the electronic configuration, the concept of electronic configuration, and I hope that you have understood how to write the electronic configuration of any element. Based on the electronic configuration, you can determine the position of the elements also. You can see it here. This is the image taken from your textbook only. Hydrogen, it has 1 electron, atomic number 1, that is 1 electron. So in its outermost orbit, it consists of 1 electron and it has only 1 shell. That is why it is kept in what? That it is kept in the period 1, group 1. Lithium has 2 shell, 2, 1. It means that its atomic number is how much? Its atomic number is 3, 2, 1. In the first shell, the electrons accommodated is how much? 2, 8, 8, like this. It is also called as the octet rule. Whenever the 8th element is completed, the next element jumps into the another shell. So this lithium has how many shell? 2 shells. That is why it is kept in the second group. So sodium, it has 3 shells, 2, 8, 1. It is kept in the third one. But if you observe this second period or the second orbit of lithium, it consists of 1 electron in. So 1, 1, 1. So whatever the outermost shell, it indicates the group number. Moving forward to the second group, see here in this one, in the outermost orbit, it has how many electrons? 2. 2, 2, like this. Are you getting it? So they are kept in the second group, and they consist of 3 shell here, 2 comma 8 comma 2, third parent. So 2 comma 8 comma 2, it indicates that magnesium has how much electron in it? 12. 2 plus 8 plus 2. Are you getting it? Is that clear, everyone? So this is a concept of electronic configuration, or you may call it as the relationship between the electronic configuration and the modern periodic table. Understood? So overall concept that we have studied in this chapter are modern periodic law. We have seen that the properties of the elements are the periodic functions of their atomic numbers. Then we have studied about the modern periodic table, long form of the periodic table, its components, its characteristics, its properties, how the periodic table is made, how the position of the elements is kept in the modern periodic table. Everything we have studied. We have studied about the structure of the modern periodic table. In the structure, we have seen based on the periods and groups how the elements are placed in the modern periodic table. Modern periodic table consists of 7 periods and 18 groups. We have studied about the structure of the modern periodic table based on the blocks. There are 4 blocks in the modern periodic table: S block, D block, P block and F block. Now, based on all of these concepts, let us study some of the questions. Some of the questions for you to practice. An element has its electronic configuration as 282. Now answer the following questions. What is the atomic number of this element? What is the group of this element? To which period does this element belong? With which of the following elements would this element resemble? Atomic numbers are given in the brackets. See here. These elements you have to see, and you have to find out that to which element these elements must belong. Okay. I will be giving modern periodic table, an image of modern periodic table here. See the next question. Write down the electronic configuration of the following elements by finding their atomic number from the periodic table. You can see the periodic table. For this question also you can refer the periodic table. For this one also you can refer the periodic table. So which elements electronic configuration you have to find is lithium, helium, nitrogen, carbon, sodium, aluminum, fluorine and calcium. So you have to find all of these elements from here. Find their find their atomic number first and then the electronic configuration. Is that clear? So this was the second lecture of your chapters, periodic classification of elements. This chapter is quite lengthy. We will need one more lecture for this chapter. I hope you understood this lecture and whatever concept has been taught to you, understood that clearly. So once again, thank you very much. Stay safe, be at your home and study well.